Example number 2, connecting polynomial functions with their graphs. We want to match each graph and with the correct polynomial functions, and we want to justify our reasoning. So, first things first, let's just group them. So I notice that I have a cubic here and a cubic here. So what I'm going to do is I'm just going to highlight them in pink. I know that it's a cubic because the greatest power is 3. On our graphs, I know that I have a cubic here because it's squiggly. It has 2 turning points. And I know I have a cubic graph here. So what I want to do is identify through using my graphing calculator. And then we'll kind of justify it as well. So when I open up my graphing calculator and I type in this one, negative x to the power of 3. I'm just going to clear it. I'm going to do g first. Okay. So negative x to the power of 3 plus 4x squared minus 2x minus 2. I'm going to graph it. It looks a lot like this one. Let's talk about why. Actually, what I'm going to do is I'm going to change my window settings just so that it looks a little bit more like it. Remember how we changed it from 10 to 50? I'm going to change that back to 10, and let's graph it. So when I'm graphing this, I'm noticing that the 2 options available to me are, I'm just going to hide that for a second. One of them goes from quadrant 3 to quadrant 1, and one of them goes from quadrant 2 to quadrant 4. And this specific one that we graphed, we're going from quadrant 2 to quadrant 4. So our g of x actually matches with graph 6. Now this makes sense because we know that when the leading coefficient is negative, we know that we're going from quadrant 2 to quadrant 4. So this one right here, this one is g of x because the leading coefficient is negative. And this one, we use our powers of deduction here. We're going to say that this one is p of x because the leading coefficient is positive. We're noticing that another identifier is looking at the y-intercept. They both have a y-intercept at -2. So that doesn't help us too much. The thing that helps us with this one is one of them is a negative leading coefficient and one of them is positive. Let's look at another type. We have this one right here. So x squared minus 2x minus 2 and x squared minus 2x plus 1. We know that the shape of anything x to the power of 2 is going to be a parabola. So we have a parabola here and we have a parabola here. Now before we crack our graphing calculator, let's just see if we can distinguish here. We're noticing that the constant term, our y-intercept, is at -2. I'm looking here, -2 is right there. There's no y-intercept happening here. So I think that j is going to be matching up with graph 2, because right here we have our y-intercept at -2. So I'm going to say that this is j of x because the y-intercept is at -2. I'm going to say that this one is k of x, so this one right here, because my y-intercept is at +1. And look at that. It is. But don't just believe me because I'm the teacher. Let's graph them. So I'm going to say x squared minus 2x minus 2. So it should look like this one. Okay, this is our j of x. Let's graph it. See what happens. Look at that. It bobs under just like this one. And let's compare. Okay, I'm going to go here. I'm going to clear it. I'm going to say x squared minus 2x plus 1. Graph it. And look at that. It bobs up above that, x-axis, and it touches only once. So we got it. Now, last but not least, we have our linear functions. So we have q of x here, and we have h of x here. Now, they're both negative leading coefficients, so we know that they're, oh, and these are our two final linear functions. So that means that we're going from quadrant 2 to quadrant 4 in both of them. And we notice that we have the same y-intercept. It's both at negative 3. But the distinguishing thing here is the coefficient in front of the leading coefficient. Now, they're both negative, but one is 2 and one is half. Remember in grade 10 when we said slope is rise over run? Well, with this one, the slope, which is identified here, is the rise is 1 and the run is 2. So if I were to look here, I'm going to say the rise is 1 and the run is 2. The rise is 1. The rise is 1 and the run is 2. This one doesn't match with this one, but let's see this one. Rise 1, run of 2. Rise 1, run of 2. Rise 1, run of 2. So our h is actually going to match up with our graph 3. Because of the slope. It's negative 1 half. This one, the slope is negative 2. So that means I would go up 2 and over 1. Up 2 and over 1. So I'm going to say that this is my q of x because the slope equals negative 2. But again, don't take my word for it. Let's graph it. So I'm going to say negative 1 divided by 2x minus 3. And let's see if this works out. Look at that. Okay, so that would be this one right here. We have, if I want to zoom in here just a little bit, or it would change the window settings a little bit. I'm going to say that my x minimum, I'm going to call it negative 7 instead. Let's see. Just so we can see exactly where that touches. Oh, I think I changed something funny. Ah, yeah, not minus 70. I want 7. There we go. Look at that. So if I would go second trace, I want to find out where the 0 is. That's where it touches the x-axis. Enter. So I have to go over here, because I have to get left of it. Oh man, this is going to take a long time, I think. You guys can just press that down. Mine has to travel a little bit. Okay, left bound. Now the right bound, I just want to go on the other side of it. Enter. Enter. And the 0 is at negative 6. And look at that. The 0 here is at negative 6 as well. So we have successfully matched all of these to the graph, simply using our graphing calculator. But we can use our sweet reasoning skills to understand the differences using the rules of leading coefficients, by using what we know about y-intercepts, and by using what we know about slope.